everybody. Today we're going to go over the greatest common factor lesson. You guys should have your worksheet out so you guys can be following along. And this is what we're going to talk about today, the greatest common factor, also known as the GCF. And when we think about factors and the greatest common factor, basically what we want to think about is what is the greatest thing that's common between everything. So we can have our numbers, we can have terms, or we can have something in a polynomial, and we want to think about what do they all have in common together. So if we take a look at our first example, we're going to talk about finding the GCF between 24 and 36. And so how we're going to start these problems is we're going to write out the list of factors between our two terms. In this case, we have two numbers. So you guys know how to do this. We have 24. We're going to make our little factor tree. What I mean when I say factors, we want to break it up into as many tiny pieces as we can. So we're going to start with 2. We know that 2 goes into 24 because it's even. So we'll say 2 times 12. And then we can break 12 down even further. So we have 2 times 6. And then 6 can break down even more to 2 times 3. And if it can't be broken down anymore, then you're done. That's it. So we have a 2, a 2, a 2, and a 3. We'll move on to 36. 36, we can break that down into 2 times 18. And 18 can also be broken down more into a 2 times 9. And again, we can break down 9 into 3 times 3. So now that we have our numbers and their factors listed out, what we want to think about is what do they all have in common? So looking at my two factor trees, I realized that they both have a 2. And then moving down, they both have another 2. And they both have a 3 also. So I like to circle them. You can underline them or highlight them, whatever you guys want to do. So now I have my terms circled, and so what does that mean? So basically what that means is the number, whatever 2 times 2 times 3 is, which is 4 times 3 would be 12. It means that 12 is the biggest number that can go into both 24 and 36 evenly. When we talk about greatest common factors, we cannot have a fraction at all. It always has to be whole numbers. But basically, we break it down into its little pieces and then figure out what that multiplies to. So if we look at another problem, this will be example 2 on your worksheet. We're going to mix it up a little bit. We're going to throw in some x's. But we're going to do exactly the same thing. We're going to start with our first number, 17x squared, and break that up into its pieces. And 17 itself can't really be broken down anymore. So I'm just going to write that as a 1 times 17. But my x squared can be broken down. We know that x is, or a squared term is just the term times itself. So that's going to be 2x is x squared. Then when I have my 34x cubed, I want to ask myself again, what can I break this down into? 34 is even. So we know it has a 2. 2 times 17. And 17 can't be broken down anymore, so we're going to leave that one. But my x cubed, again, that can be broken down into x times x times x. So just like in the last example, we're going to go through and we're going to circle the terms that they both have in common. So going across, I see a 17 on both sides. An x over here goes with one x over here, and then an x over here, and a second x. So now I can write that my GCF, my greatest common factor, between these two terms, 17x squared and 34x cubed, is going to be 17 times x, or we know from our exponent properties that that's 17x squared. Okay, so we just finished example 2. What I need you guys to do now is pause the video, write down any questions that you have, and if you need to rewatch it, do it. But write down your questions on the worksheet and we'll go over them on Monday. And then obviously turn it back on and finish the rest of the worksheet. Because so we were dealing with numbers in the last problem and terms in this problem with our x's. But now what happens if we throw in some pluses and minuses? And really, guys, it's the exact same process. We're just going to go through, list out our factors, and figure out what they all have in common. So we'll start with our 4x to the 5th. 4 is 2 times 2. 2 times 2. And x to the 5th, you're just writing out 5 x's. 1, 2, 3, 4, 5. 4x to the 5th, done. Move on to 8x cubed. 8, we know, is 2 times 4. And we can break 4 down a little bit more into 2 times 2. And then my x cubed, just like my x to the 5th, we're going to have 3 x's. 1, 2, 3. And I'm running out of room here, so I'm just going to do my 2x down here. But really, can 2x be broken down anymore? I know you can't answer me when I ask you that, but it's just 1 times 2 times x. So same process. I'm going to go through and I'm going to circle what I have in common. I have a 2 here, a 2 here, and a 2 here. I would like to circle this other 2 because I know I have it in my x squared, but guys, there's not another one left over in my 2x, so that's as far as I can go. What's important is that they are in every single piece of your trinomial or your whatever size polynomial you have. It has to be in every single piece. So I can't circle that other 2. But what I can circle is I can circle an x, because there's definitely an x in each term. So then looking at this, I've circled everything that I have in common from every piece, and I can say that my GCF is 2x. All right, so moving on from here now, I'm going to ask you a question. I'm going to say, what is left? If we take out a 2x from every term in this polynomial, what am I going to have left? Okay, so what we're going to do now is we're going to move on to example 4 in your, on your worksheet. If you notice, the polynomial is exactly the same from example 3, and we just figured out that our GCF is 2x. So again, the question is going to be, what is left? What we're trying to do in these problems is we want to factor out our greatest common factor. We want to take out this greatest common factor from each of the pieces in the polynomial. And how we do that is we essentially reverse exactly what we've been doing all last week. So last week when we were multiplying polynomials together, we had a box. And we figured out what our box was by how many terms we had. And the difference in these kind of problems is before we had our polynomials up at the top and then down the sides. Now what we're trying to figure out is what multiplies to get our original polynomial. So I'm going to write my 4x to the 5th, my positive 8x cubed, and my negative 2x right inside the pieces of my box. Essentially what we're trying to figure out is 2 times what equals our original polynomial, our 4x to the 5th, plus 8x cubed minus 2x. So how we're always going to set it up is our original polynomial is going to go right inside of our box, and our GCF, our 2x, is going to go on the outside. And if you remember from multiplying polynomials, the way that we used to fill in these boxes, fill in the inside of our square, was we multiplied our outside numbers together to fill it in. So now we're just kind of reversing it. So I want to ask, what is 2 times what equals my 4x to the 5th? So obviously we need a 2, because that 2 times 2 is going to give me my 4. But what's going to give me my x to the 5th? If you remember, there's the imaginary 1 right on top. So 1 plus what equals 5, really? Because we always add our exponents when we multiply by a common base. So I know that the first piece of the polynomial that I'm looking for is a 2x to the 4th. And guys, we can always check this by multiplying these two numbers together. 2 times 2 gives us 4. And then x to the first times x to the fourth, we add up our exponents and get x to the fifth. So moving on to the second piece, I'm going to ask again, 2x times what equals 8x cubed? Well, I need a 4, 2x times 4, so 2 times 4 is 8. And then x to the first times x to the what is going to give me 3. And that's going to be x to the second. And again, we can just check them by multiplying them together. Moving on to my second one, I have a 2x here and a negative 2x inside of my box. So what's missing? The difference is that this guy is positive and this one is negative. So how do I get that to be a negative? Well, I just multiply it by a negative 1. And going through again, we can check every single box to figure it out. That, our final answer, I'll write it up here. Final answer. We found our two polynomials. We have our 2x times 2x to the fourth plus 4x squared minus 1 is going to equal my original polynomial, my 4x to the fifth plus 8x cubed minus 2x. And that's greatest common factor. You guys have a few more problems on your worksheet, so we'll work on those for Monday, and we're going to go over this again in class. Have a good weekend.